We're going to finish up our chapter on rational equations and expressions by looking at you solving rational equations in a problem-solving context using real-world examples, as well as manipulating variables within formulas that are rational expressions and equations to highlight a specified variable. We're going to be following a lot of steps that you see here with solving rational equations, the first and most important part being multiplying all the terms in the equation by the least common denominator of all the denominators. Then we're going to be using a combination of distributive property, combining like terms, addition and multiplication properties to isolate the variable. It's very similar to a lesson we did earlier in the year on formulas and literal equations. Now we're just including rational equations into the mix. So when it says solve for the requested variable, like we have here, and it says we want to solve for x, that means we need to end up with an equation that is x equals something, and everything else is on the other side of the equation. So the first step is to identify the LCD. Well, we've got three fractions, all with unique factors, which means our LCD is the product of all three of those denominators. So we'll multiply everything by the LCD. So we have our first fraction, our second fraction, and our third fraction. All of them will get multiplied by x, y, z. And then we'll go through and simplify. And we'll see what eliminates and what we have left. 1 times yz is yz. 1 times xz is xz. And 1 times xy is xy. Now we're solving for x, so the next thing we want to do is get all terms that have the requested variable on the same side of the equation. All terms that don't have that variable we want to keep on the opposite side of the equation. So we'll subtract xz from the left side, so it eliminates, and move to the right. Now these aren't like terms, so I can't combine them. But a little trick that we can do, notice we have the same variable that we want in both terms. That's a common factor. So in order to remove it, we will factor out that common factor of x. That allows us to take two terms with the variable down to just a single factor. And then our last step is we take our equation and we need to get x by itself. So we will divide both sides of our equation by y minus z, which is being multiplied by. That way we're left with x equals yz over y minus z. A lot of times in physics and chemistry, you'll see formulas that have these subscripts. These subscripts just indicate that they're representing two different things. And so they don't count as the same variable. They are not like terms. Sometimes you'll also see an uppercase and a lowercase letter. Again, those are not like terms. Uppercase and lowercase have to be treated as if they are completely different variables. So we want to isolate t squared. We look for our LCD is t1 and t2. And so we're going to multiply everything by t1 and t2. So we'll do a little bit of a shorthand here. We don't need to rewrite the equation. We're multiplying both sides by t sub 1 and t sub 2. On the left, the t sub 1 eliminates, leaving us with t sub 2 times p1 and v1. And on the right side, t sub 2 eliminates, leaving us with t1 times p2 times v2. Then to get t2 by itself, we'll just divide both sides by p1 and v1 so that they eliminate from the left, leaving us with t2 is equivalent to t1, p2, v2 over p1, v1. Again, p2 and p1 are considered to be different variables, as are v2 and v1, so we cannot simplify and remove them. They are not the same factors. Same idea, we want to isolate f2, and so we're going to have to first clear our fraction. So we'll multiply both sides by f1 plus f2, f1 plus f2, that is our only denominator, so that eliminates it from the right side. So we have f times f1 plus f2 equals f1, f2. Now we need to get all terms with an f2 on the same side of the equation. Problem is, I can't move this first term because there's this multiplication in the way. So we're actually going to need to apply distributive property first, f times f1 plus f times f2. That way we can now move this requested term, or this required term, over to the right side of the equation with the other term that has f2 in it. So we're left with f times f1 equals f1 times f2 minus f times f2. We can now factor out the common factor of f2, so that we're left with f1 minus f, and then we finish off by dividing out the factor on the right, so that we're left with f2 equals f times f1 over f1 minus f.